Hi, this is Paul. This video is exclusively done for my friends at workplace who are already familiar with line design and things associated with line design. Here in this session, I'll be covering few key points which will be helpful in implementing line design at shop floor. I'll be covering a line design and the principle incorporated in it. Then we'll discuss about the practical problems one would face in shop floor while implementing line design. And it is very important to understand the difference between bottleneck and abnormality while dealing with line design or while implementing line design. And the fourth point is how to bring down OCTs below takt time. You're right now seeing a line design with a takt time of 41 seconds. As you all know, takt time is something which you can decide as per the customer demand. So this line design has about 46 workstations, and the highest SAM in this line is at 41 seconds. The least is at 17 seconds. The first operation in this line is at 36 seconds. Actually, the OB, as per the OB, this operation is 72 seconds. So by having two workstations, it becomes 36. So the logic is wherever you have two operators or two workstations for one operation, this is how the bar would look equal 26 26. Here you have two bars, which means there are two workstations for this work, each one sharing 26 seconds of work content. If you choose that this operation shouldn't be the bottleneck in this line, you can have another workstation here, and this 41 would become 20.5, and eventually the next bottleneck would become 39 seconds. So this will continue. So basically the point here is every line design will have one bottleneck. So in this case, the bottleneck operation is the 30th workstation with 41 seconds. The second thing to know about line design and takt time is that all the operations has to be below the decided takt time. So logically, if everyone works below the takt time, this line should be producing 87 pieces per hour. Anyway, we'll come to that pieces little later, but it's important to understand how line design actually works. It has takt time, it has certain balancing happening, and there is always a bottleneck. So this is about line design. Practical problems faced while implementing line design is something which is very key in this video. if you see this line design, every bar is unique. We don't see that even though all the operators are below takt time, each one have their own SAM. For example, this operator has a SAM of 17 seconds, the least in the entire line, which means that this person should be very relaxed in the line, or this person should be waiting for work. And on the other side, this operator who's at 41 seconds will be very busy, or the most busiest person or most busiest operator the entire line. But when you really walk through the line and look at the operators, you might see that everybody in the line has equal amount of work. You might see everybody in the line, be it this person or this person, they'll have equal WAP levels. They'll have 3 to 5 pieces, and everybody in the line will have some pieces waiting for work. So what is happening? Even though your line design says that this person has less work, even this person is busy in the line, even this person who is supposed to be waiting for work, even this person will have some 3 or 5 pieces as WIP. What really is happening there? How is that even though the line design says that these people at 17 or 21 or 18 seconds is supposed to have lesser workload, how come even they have same amount of workload as the higher SAM operations? So what really happens here? This is very key to understand. There is always a tendency in the line that everybody in the line would align to the speed of the highest SAM or OCT. This operator who's at 41 seconds is the actual person who sets the demand for all the preceding operations before. So what happens? Even the person who's supposed to be working at 17 seconds does it at the speed of the demand 41 seconds. And eventually the entire line works around the speed 41. And if you take an OCT, almost 80% of the operations will be higher than takt time, and almost every operator will be higher than their own SAM. This would be the scenario when you walk through the line commonly, or this is the scenario you would come across most of the time. This is when you need to go back to line design and check, why is this operator busy in this line? How come everybody is working at same speed? What is wrong with the line? So to understand this principle, I would like to give an example of traffic, the Bangalore traffic. Whether you go in BMW or Mercedes or Audi or any automobile, everybody in the traffic goes in the same speed. The fellow causing bottleneck decides the speed of the traffic. I hope you'll agree. I repeat, the fellow causing bottleneck in the traffic decides the speed of every vehicle on the road. So is this. This operator working at 41 seconds influences every operator on the line to work at that speed, and therefore you will find no bottleneck at all. When you walk through the line, you will never see visible bottleneck, even though we are very familiar saying that every bottleneck is visible. In this case, you will never find a bottleneck. You will find everybody busy, no breakdowns, no bottleneck, and you will think that the line is balanced, and you might think that this is the optimum level of output or efficiency a line can achieve. No, that is not so. The moment you find everybody busy in the line, or the moment you see even this fellow in the line is busy having some WAP in hand, it's high time you speak to your operators that your time is 17, and why is your OCT at this level? This is the time you need to pull out your line design, take it to the operators and tell them, this is your time, this is your time. And this operator is the one who's supposed to be working at the highest OCT or highest SAM, who in turn decides the output of the line. I'll be touching this point little later and much deeper. For time being, I'll just move on to the next point. Bottleneck versus abnormality. While dealing with line design, or while dealing with design deficiency, it is very important to understand the difference between bottleneck and abnormality. Bottleneck can be predicted during pre-works, isn't it? When you see a garment or when you see the OB, I think anybody can predict so-and-so operation is critical, so-and-so operation might take a longer time to do, so we need to put 2 workstations or 3 workstations, because you can predict the bottleneck. And as I said earlier, every line will always have a bottleneck. So bottleneck is not an accident. Bottleneck is integral. Every line will have bottleneck. It is up to the designer or the shop floor manager or the shop floor engineer to decide which operation you want to be called as the bottleneck. In this case, the designer has chosen 41 seconds, has chosen this operation to be the bottleneck. You can choose any of the operations to be the bottleneck and balance accordingly. So the point is, bottleneck is not a surprise. Bottleneck is something which can be predicted. Bottleneck is something which you can control, and bottleneck is something which you can monitor. And talking about abnormality, you really cannot predict when a machine will break down. You really cannot predict when your operators might fall sick. You really cannot predict when there will be a power cut. So those things which you really cannot predict can be called as abnormality. So the reason why I am explaining the difference between bottleneck and abnormality is both has different solutions because both are different problems. Abnormality is got to do more with shop floor management, and bottleneck for these reasons is something which is designed, implemented and controlled. So when the line is not producing the desired output or the designed efficiency, you need to identify your bottleneck and you have to identify your abnormalities discreetly without mix-ups. Only then can we take the right actions. So that's about bottleneck and abnormality. It is not possible to design a line at 100% efficiency, but it is possible to optimize. Line design is all about optimization. You choose the takt time and you balance accordingly. So this is one key thing one has to understand, that it is not possible to design a line at 100% efficiency, but it is possible to optimize. So line design is basically a tool or a method which helps you to optimize your line. How to bring down OCT with respect to takt time. The earlier slide I was telling that when you take an OCT and compare with LD, SAM, every operator would be about takt time, or everybody would be above their own SAM. So how do we overcome that? Do not give targets to operators in terms of pieces the traditional way. We are used to talk to our operators asking for number of pieces per hour. We would say I want 60, I want 80 pieces, 100 pieces per hour. And most of them, they trust you and they give their best shot to achieve that. Sometimes they do achieve, sometimes they do not. Here, the key is, instead of telling them how much to produce, talk to them about takt time. And also tell them what is the SAM of their particular operation assigned to them. Every operator in the line should know their own SAM, and they should also know the takt time. They need to know the two values in terms of seconds or a time instead of pieces. Because the moment you talk about pieces, if this operator is giving 60, this operator will also give 60. So talking in terms of pieces, the entire line would say that they do what is given to them. Operators would say, I will do what you give me. If you give me 50, I will produce 50 pieces. If you give me 60, I will produce 60. So here, the key to bring down OCT is, do not talk in terms of pieces to your operators. Talk to them about takt time. Talk to them about the SAM of the operation assigned to them. If possible, show the line design. Let them see this chart. Let them see that this is you, this is you, this is you. So make the operators more conscious about their time, make them conscious about the number of bursts and the extra motion elements. If possible, give instructions about the number of bursts to be taken for their operation. The familiar slogan is method determines time, which you would find in GST or any PMTS. So they need to know that their methods determine time, the number of bursts, the time they take for every cycle is what decides the output of the line. And the fourth most important point is, after taking an OCT and compare the takt time, we have the tendency of, or we have the habit of telling every operation is about takt time. No, that's not the way to do it. You might have every operation about takt time, but always pick or identify that particular operation which is about takt time. Just pick one at a time and bring down that operation below takt time. So as I mentioned earlier, the slowest operator in the line is the one who influences or controls the rest in the line. So it is important and very critical to identify the slowest operator instead of identifying all the operations about takt time. You might get lost and it will not work for you. So always pick one at a time and work on their OCTs by minimizing or eliminating extra motion elements, right? So these are some tips to bring down OCTs against takt time or their own SAM. So a recap, it is important to identify the difference between bottleneck and abnormality. They are different. Bottleneck can be predicted, designed, implemented, improved, and controlled. Abnormality is more to do with floor management and not LD. And this is the most important thing. A line supervisor should always be mindful of the bottleneck operation in the line with respect to LD and OCT. In the sense, when you call a supervisor and ask him, tell me the bottleneck operation, he should tell the bottleneck operation, and he should also tell the OCT of the bottleneck operation. Because the moment he knows the bottleneck operation, which means that he is actually controlling the output of the line. Rather, he is actually making the output rather than accepting whatever the output is coming. And it would be even more wonderful that if the highest SAM operator, in this case the 41 seconds operator, if that operator knows that if you teach or coach the operator that it is you who decide the output of the line, it becomes much more easier to implement line design. Instead of calling everybody the line, or even if you call everybody the line and talk to them, tell them that this particular operation, doing so and so operation, will do the highest SAM operation, and everybody else is balanced below that. So therefore the target of the line will be decided by this operator who has 41 seconds. So when you start implementing line design in this direction, when your supervisors and when your workers or operators at shop floor or line understand about the highest OCT or the highest SAM, your line management becomes much easier. The last point and the most important point for industrial engineers and supervisors or any manager: the moment you see the line design, you have the habit of looking at what is the target, and seeing the target, the first thought which comes to your mind is it is not possible, because there's a huge gap between what you have been doing and what is designed in line design. Rather, when you see a line design, before seeing the number of pieces to be produced, look at the takt time. Look at the operations which are very close to the takt time. Look at the operations which are way below the takt time. So by doing so, you will have an idea how to go about implementing line design, how to achieve design efficiency. So design efficiency, or the target pieces in line design, is not baseless. It has basis, and the basis is the highest SAM in the line, which you have chosen. The highest SAM is called as bottleneck in our context. So basically, a line designer or the one who's implementing line design decides the bottleneck operation and eventually decides the target of the line. I hope all these points will be helpful to you as you walk through the line and implement this. Thanks for watching. And if you do have a different view, or if you need more clarification, you can always call me up. Since this is done exclusively for my friends at workplace, you can feel free to talk to me with your views, and I'll be happy to discuss and also learn from you. Thank you very much.